This is a recap of Tuesday, October 20th. We went right in at the beginning to CAMI week 5, and we skipped pages 1, 2, and 3, and we'll come back to those later in the week. And we worked on page 4, and I'll just write in the target here, and the target is to add real numbers. And write all mixed numbers as improper fractions and rewrite the fraction using the least common denominator. If the fractions are negative, place the fraction sign on the number in the numerator. And use integer rules. So this is a new idea. We learned about integers last week, but now we're going to apply those rules to fractions. And write the sum over the common denominator. And then write the fraction in simplest terms. It just means to simplify it. So then we did a couple of problems. Well, we did one example of this. Zoom in a little closer. You can see a little bit better. So we don't have an improper fraction here, so we can just go ahead and get started. We have -5/6 and 6/3. The common denominator is going to be 1/6, so we can take 1/3 and change that into 2/6. So we have -5/6 plus 2/6, and I'm going to rewrite that and really make it obvious that the negative goes with the 5, the numerator. And the reason for that is because we are going to, let's go with red here. So this is the focus. We're going to view that as -5, turn my 2 into 5 there, plus 2. So -5 plus 2. There's more negative than positive, so that's -3. So that is -3/6, which can be simplified to -1/2. There's 3 ways we could write it: (1/2), (1/2), or 1/2. This is the way we're usually going to see the answer. Next, we're going to deal with decimals. So determine the sign of the answer and then find the sum. So if the decimals have the same sign, find the absolute value of this number and use the sign determined up here in step 1. If the decimals have different signs, for example, if one is positive and one is negative, then we subtract the lesser absolute value from the greater absolute value and use the sign determined above. So that's just like we learned with integers last week. So what we did in class was we drew a sketch. So I'm going to draw a sketch right here of, let's pretend that this is 14.7, and I'll fill it in with a positive color. And then I had students tell me if I was to draw this -3.5, would it be smaller or bigger? I'm going to make it red, I'm going to make it negative, but they decided that it would be smaller because 3 is smaller than 14. So I'm going to fill this in. And when we combine these, when we add them together, when this goes on top of this, it's kind of like it cuts out a section of this and it zeroes it out, and this is all the stuff that's left. That's the answer. So it's going to be a positive amount, but it's going to be less than 14. So we're going to find the difference. 14.7 minus 3.52. A couple weeks ago we worked on this. We have to add in zeros. Whoops, this is a 2. Let's erase this. Where's my eraser? There we go. And we'll add it, we'll erase that. Okay, so this is a 2. Can't take 2 from 0. So to borrow, rename. 10 minus 2 is 8. 6 minus 5 is 1. 4 minus 3 is 1. So it is a positive. We know the answer is going to be positive, 11.18. And notice how it got smaller than 14. And that's as far as we got on Kami today. What we did next is we went to an activity on Desmos that I'm going to go to right now. And it was not a assignment, but an activity. And I do want to share the activity if you're watching this. It was called subtraction to addition. And what we learned was that, or what this is about, is that every subtraction problem can be turned into an addition problem that has an equal answer. So let me pull these out here a little bit and let's look for the subtraction. So there's subtraction, and there's another subtraction problem, and there's the third one. There should be 4 of them. Okay, so these all have an addition problem that is the same. So I'm going to highlight something here just temporarily, and let's just go with yellow. But what I want you to notice is that this is going to stay the same. This is a -6, that's a +6, this is 18, and this is 18. So when I go to find the problems that match up, that has to be the same. So that 6, I'm just looking at it, is the same as that 6. So let me go like this. So that matched up. So the first number cannot change when I'm trying to find the matching addition problem. And there's a -6, and that's going to match up right there. And again, let me highlight it. It cannot. That's -6. Whoops. Let's put that there and get the highlighter. Okay, so notice that that is the same. And this is the only part that is different. -12 is the same as plus a -12. Let me get a different color here. And we'll just go with, let's say this blue. Okay, so this is +12. This is the opposite of +12. This is +12. This is the opposite of +12. Notice the only thing left is the plus and the minus. Minus, plus, minus, plus. Let's see what that's. This is going to be a +12, so I'm going to look for a -12. Here we go. So whoops, let's get rid of that. And let's get this. And then the last one let's get the highlighter again. The opposite of negative 6 is 6. So notice how, here, let me go to this red pen. Okay, so notice how this is the only thing that, this changed, not the only thing that changed, it changed to a plus, and this is the opposite. This stayed the same. This changed to a plus, this is the opposite. This changed to a plus, this is the opposite. That changed to a plus, that's the opposite. So now this is going to have one answer. So 6 minus 12 is negative 6. So that goes on that one. Negative 6 plus a negative 12, that's a negative, and even more negative is 18 negative. And 18 minus 12 is 6. And 18 plus 6 is 4. So there's the answer key for that first slide. Oops, there we go. It's kind of nice and organized so you can see it. And then the last thing that we're going to talk about on today's recap is the problems that I had whiteboard up and asked people just to volunteer, and so I'm just going to open them all up. This is from all my periods. We did a total of, looks like 7 problems. I took screenshots of all the problems that we did. I think that's all of them. So I'm just going to open these all up, and then we'll make a quick comment about that, and that'll be it for the recap. So this one was a really interesting one because the question was just how about 2 minus 2? And we noticed that 2 minus 2, we know it's 0, but we noticed that it's the same as 2 plus a negative 2. So if we have 2 positives and we take them away, that's the same as if we have 2 positives and we add 2 negatives. Those cancel out. On this one over here, we changed 4.6 minus 2.4 to 4.6 plus a negative 2.4. So we had a picture here of 4.4 and then kind of taking a 2.24 bite out of it. So that was that one. This one showed how we're looking at the integer rules for the numerators. So when we have 1/4 minus 2/3, we change it to negative 1/4 minus 2/3. We change it to negative 1/4 plus a negative 2/3. Has to have a common denominator. And then once we get that common denominator, we kind of just look and focus on the negative 3 plus negative 8 is negative 11. Same with this one. We had 10/12 minus 9/10. The common denominator, we used 120, we could use 60, but once we had that, remember we take the negative and we put it with the numerator, so that becomes 100 plus negative 108. So when we combine those together, we get a negative 8. So negative 8 right here over 120, and then we simplified it to negative 1/15. This is a good example of how when we subtract a negative, it's the same as adding the opposite, which is going to be positive. And it takes a little convincing sometimes, and we did that same example from period 1. And then we also did 18 plus a negative 12. So when we have, this is a different problem right here. And when we have 18 positives and we chew out 12 of them, we that negative and that positive just cancel each other out. We have 6 left. This example was, seems like one that I've already gone over. I think that is the same as that first screenshot. So maybe I took a couple of screenshots. Maybe we just did some very similar problems on this one. It looks like we've kind of thrown everything in there on this one. We've got subtracting a negative. We've got that example of 2 minus 2 is the same as 2 plus a negative 2. We also have 2/3 plus minus 1/4, and this comes from the Desmos activity that we did today. The second slide, which we'll work on tomorrow. And the last one that I put up here is a good example of taking the negative and putting it in with the numerator, keeping it right there. We got to have a common denominator of 8. 5 minus 6 is going to be -1. So that's -1/8. Okay, that is the recap for Tuesday, October 20th.